Hello, welcome to another session, and so let's wait a few moments and then we'll start. Okay, I see people are joining, and guess we can start. So they have one session of this long week, so there was 4 sessions, so that's the 4th session in a row, and quite interesting experience for me and also just for us in general, because that was quite an intensive week. So today we will finish it. Alright, so and the plan for today is that we will start with the naming conventions in C#. Basically, we will quickly go through the documentation suggested by Microsoft, and you'll also see it in almost all the .NET implementations. And so we'll explain why it is needed, why it is used, and how you should proceed. Then we will have a small topic on the algorithms in general, basically how we plan and how we construct the algorithms to make the programs, because the base of each program is algorithm. And then we go to our first major topic, which will directly be related to the programming, because previously we only talked about the key parts can be used, but we actually did not do any let's say meaningful or serious programming. So we'll start it with this actual branching topic, because without it, there's no really heat of the programming. So the really start of the programming starts at this point when we can actually build some algorithms. And you'll actually see that the topic about the algorithms is the introduction for the topic about the branching in general, and you'll see why. So, and then we will majorly use the logical operators. We briefly talked about before, so you'll see why we mostly use these and or the not conditions, why we use booleans. So you'll see the main examples there. Basically, how can we manage the code, how can we actually build the algorithms using the programming. So this is about the agenda and also about the practical exercises. So I already touched one practical exercise about the algorithms. So maybe I will explain it at the end of the session. So yesterday I told you about the practical exercise that I may create for the Java C# operators topic. Basically we discussed yesterday about the basics about the math and all the logic. Maybe we will include it under the actually all these things will be included under algorithms and branching tasks. So That's so yes, we do not need to separate activity for them. So that's why it will be something called algorithms and also under the operators and convention. Alright, so let's start first of all as I promised. Let's start with the naming conventions, and here I will share the link with you. So that's official guide from Microsoft and fundamentals what are the naming conventions should be used there. And basically, so let's maybe shortly introduce what the naming conventions are. Basically, in different programming languages first, then different environments. If we work, for example, in this case with .NET, platform, C# language, then we have one exact style of coding. The same way would be if we program on different type of language, if it's programming language like JavaScript or C++ or Java or PHP or Python or whatever it is. In each language, you'll see that in general for the code there are some strict, I'll say, some strict rules about how we basically should use the namings. And as you remember what the namings are, the namings is basically all the names of the objects used in C#, in programming in C#. So again, example, if we should name the classes in some way, then we should name the namespaces, we should name the variables, for example, then we should also name the methods and structures and so many different things we can consider as some kind of objects, some kind of structures which we can name. And so yeah, the question from the developers may be, how should we actually name them? Because yeah, obviously you can imagine your own variable name, which is most your own name, which is the most relevant from your point of view for example, for the class or for the variable. So let's, for example, see how this would look like. So let's say if you define the integers, so let's say I want to define one integer as, for example, something like this, then you say another integer will be defined like something like this way, then another integer would be something like this, yeah, so just, and of course if we then work with these variables after that, then of course you'll see that this does not look quite well, right? Because you see that this starts with lowercase, this starts with uppercase, and there is a little bit of chaos here, and a little bit of mess as well. Yeah, so to escape all these things in the programming, we use the name conventions, and for different environments it can be different. And the key point first is the same as for the code formatting. Okay? So as I said, we use code formatting, so if not see something like this, for example, and because first I take a look on the code, and I want to actually quickly understand the structure of this code. I want to quickly understand the meaning of this code, and of course, then I should have the formatted code to see the structure. So see that this section is under this section, so this is the part of this section, then these all are under the same section, and it's not all, it's not included somewhere, and so I can see. The same is for the variables, yeah, if I see, so if I see something like this, so then I quickly can understand that this is the variable. So if I see something like this, I can understand that this is the class, and so on. So using the naming conventions, I can can more easily understand the structure and the meaning of the elements inside the code. So that's, I guess, pretty straightforward. And now let's quickly go through the naming conventions used in C#. So first of all, for the classes, and yeah, so when you write the code, so I suggest you to, I mean, that's not quite strict. Yeah, I mean, if you step off from these rules at some point, and if you maybe forget to apply some of the rules here, don't worry. I mean, for the beginning that's fine, but time by time, it's always better to stick to the format used in the language you write. Also, this can be different in different environments. Like if you maybe that's not really about .NET, but there are some languages and there are some frameworks where you can actually you have different projects, for example. So, for example, you work with one stuff at one project, and there you have these and these naming conventions. Then you go to a different project, the naming should be different. Maybe that's not mostly related to the general rules, like in this case, but this will be, for example, for the variable names. Yeah, so one project will say this should be, let's say, street 1, street 2, street 3, for example. Another project you should have street A, street B, street C, something like that. So this can be different, and in many different projects you will need to follow the rules. So let's then move on. What do we have here for the classes? In C# we use Pascal case. What does it mean? It means that we should start with the uppercase letter and a capital letter, so the name of the class should start with it. And then to separate the words, so we have the first word, dated, and the second word, service. We can separate them this way by simply start the second word with the capital letter. So then the same for the record structure. And for the record, you should also use the Pascal case. And then also for the structure, basically the name of the object, that's the structure, plus void interface. Then it should use Pascal case. Okay, yeah, then when naming public members of types, which is field properties, events, and all functions, they also use Pascal case. So this is about the element of the class. Here we'll talk about the elements of the class a little bit later. What do they mean? But for them the naming should also be they should be named using the Pascal case. And also for the functions, for the voids, also we should use the Pascal case. Yeah, so I want to write the position records, we should use Pascal case for parameters, the public properties of the records. Yes. And about the public properties, we'll talk about them a little bit later, so we can take a look on them. So yeah, when we discuss it. So after that, then we can also have camel case in such cases. And camel case is used for private elements. So camel case actually means that you start with lowercase, and then to separate the words you should use you should start with lowercase and then separate the words using the uppercase. So that's for the private elements. This would be yeah, so you can see we use camel case. Same here, we'll start with lowercase letter, then in the middle we'll switch to we'll change the letter to the uppercase, and then we separate the words. So straightforward. And also for the method parameters, we'll see also camel case should be used. So then you can also find some additional naming conventions. We'll maybe take a look on them a little bit later. So first of all, for now, we should know about the Pascal case for the object names, I mean class names, interface names, and so on, method names. So then camel case to use for the parameter attributes and for the method parameters. Yeah. So and then also for the simple variables. For the simple variables, we actually also use camel case. That's why on the previous sessions we can see that we almost always used camel case in this case. That's for the local variables. Okay, so this is the guide. You can take a look on them when we start working with some different structures. Also, I will help you navigate here a little bit later when we go to the corresponding elements in C#. So please let me know if you have any questions about this. I see from Elena that the page provided in the home task is not working. Okay, I will check it then, Elena. Thanks for information. Maybe about flowcharts. Yeah, that was the task about flowcharts, and we'll then explain it a little bit later at the end of the session. Yeah, so it was about drawing. You can also use any chart building tool, but yeah, I will then explain it at the end of the session. So that's about naming conventions. You can find them under the notes and resources section in the Discord channel. So you can take a look on the link there. Alright, so then we'll use all these naming conventions. And now let's move to the presentation about the algorithms. So I already mentioned the algorithms, and this is basically, as I said, on what the programming is based on. So what the programming is in general? In general, it means that we, as the programmers, we want to provide some kind of instructions to the computer, to the machine, yeah, to explain the path how to achieve something, what to do, basically. If this to that, if something else, do something else. And so when we build the algorithms can be different. So in everyday life you have planning, right? So what you will do tomorrow, for example, how you proceed step by step. The same as in programming. You do not really need to strictly plan it before you do, but you should basically understand the concept, how you should plan something, how you should build the plan for the computer to do some steps. This is the same as for your everyday life. So you cannot really say that you absolutely do not know how you should proceed, let's say, after the working day, for example, tomorrow. Yeah, you know that you have some options, for example. Yeah, you can, so yeah, tomorrow's the end of tomorrow's Friday actually done, so you may actually decide what you want to do at the end of the working day or working week. So if it's maybe to go and go somewhere else to relax, then maybe you want to have some physical activities and so on. So you actually, even right now, for example, you have some options, some cases what you expect to do tomorrow, and the actual result, what you will do at the end of tomorrow, will be based on. So maybe you already know. So in this case, you really don't have any different paths to go, but you may have such case like you have multiple options and you do not really know what you will do, and this will be based on some conditions. Yeah? And this is what the algorithms is about. Yeah? So you actually, yeah, of course, you don't know exactly what will happen, but you have the algorithm, you have the plan, how will you proceed. And this is what the computer means, yeah? Because, of course, as I said, the computers mostly work with the data, and because obviously the data is not static, data is changing time by time, and of course there may be some different actions done by the computer based on data provided. Yeah, and so for all the actions, computers also have the algorithms how they should proceed. Yes, and as a result, so once you have the algorithm built, so you will have the input. Yes, so that's what comes to the algorithm, and then you have the output. Yes, for example, for input data, this will be the program, for example, about what you will do at the end of tomorrow. So this will be based on some, or maybe something what will happen maybe today, maybe tomorrow. So, and these are all these input parameters which actually go to this algorithm. Then you will have the output, which will basically be where you will spend them the end of tomorrow, as an example. So the actions you plan to do it. Yeah, that's the algorithm. Alright, and that's a sequence of computational steps that transport input into output. Yeah. So you have the input, some kind of conditions, and then you have the output, which is actually the result. And yeah, algorithm, that's the actual tool for solving a well-specified computational problem. Yeah, that's for the computer science, for the programming. We want to solve some specific problem, but we can generalize it also outside of the computation. So this would be, as I, for example, said, your day planning or something like that. So the key idea is that we specify the problem, in general terms what we want to achieve, and what maybe also what we do not want to have, so we don't want to have any problems, for example, or something like that. And so that's why we actually provide the raw information to the algorithm, what should be achieved as a result. And again, it can be based on some conditions. So then, let's move on. Why do we actually need it? So why do we actually need to go the steps to then proceed with the actions? So first of all, most of the information built on good algorithms. That's true, especially if you heard about machine learning. Then so that's totally full of algorithms. Also the mathematics is used here, statistics, all this stuff. And of course, if you use statistics, then it's by default the statistic models used there, and of course they all built on algorithms, so calculate something and get the result, then compare some things, and based on the comparison you will the program will go one or another way. Also studying algorithm comes from the ancient history. That's also true, also foremost by George and Turing in the 1930s. And the key point here is that if you think algorithmically, it makes your actions more efficient, what you do, and more effective in achieving goals. Because it's always much more productive to have the plan than to just have no plan. You know. But that's quite obvious thing. And so, just basically to describe the algorithm in general, it means that you said you want to achieve some kind of result. So, for example, that's the beginning of your algorithm. You start at this point, and then what you want to achieve using the algorithm, you want to finish at this point. So the algorithm would be actually to provide the paths, what are the steps to be done to go here. In this case, it's quite complicated thing. Of course, it's not that you always have something like this, but yeah, that's the conceptual image how this should look like. And yeah, so the key point here is you should find the path. Then the second point is that there can be some network connectivity problems, so something is not really connected. Then we can solve the automation and optimization problems. Yeah, so for example, and that's at least what I experienced from my friends who work in outside of IT, for example, it can be banking, and yeah, they say that they sometimes do some kind of monkey job. Okay, if it's something on Excel or data processing. So the idea is that they simply do the things which they basically do the same things every day. So they, as one of the examples there was, they receive the data, and then they look on the data, they see if there are some crazy data here. There, for example, they receive, so the crazy means that the numbers they see there are not reliable, are not really correct or something like that, and so then they just report that entries. And of course this can be done by the algorithms, by the programming algorithms, so all these things can be optimized, and then people just don't need to do a monkey job. A monkey job we usually call it in programming and in IT, that this is a job where people just do without any thinking, they just do same things like for hours, for days, maybe for months, and so this is the job which in general can be replaced by the computers, and of course by the things that the algorithms for such solutions can be built. Yeah, so then we can see also big data problems and this machine learning in general, and this is what I already mentioned. And so for example, you have a problem in mind, you try to solve. For example, you have something that, yeah, this is what I said, yeah, the problem may be that you don't know what you want to do at the end of tomorrow, for example, and you can build some steps like, for example, if I meet these or these friends, then we will go there. If I meet the colleagues, for example, then we will go to another place, something like that. Yeah, and actually, this may be quite philosophical thing. Algorithms may unlock the secrets of life and the universe. Well, that's maybe so not straightforward. So maybe I will leave it to you. Thinking about the secrets of life and the universe, because not the point I can really discuss. So and here you can see some quotes. You can take a look on. So basically, the key point from here, the key point is that that algorithms help make our life better, help make our life more productive, and from the business perspective, of course, so every business wants to reduce the costs and get more profit. That's obviously, and of course, if the technologies are used, so it means that monkey jobs will be done by the computers, and of course, it costs less to to actually create the algorithm which produces the solution for many months and maybe many years as well in the future. So that's why it costs quite more OS, and that's why we actually need the algorithms. Yeah, basically they're used everywhere now. And yeah, so basically how the science is built. For example, in computer science and in mathematics. So if you study it in university for the last 5 years, then you will probably notice that if you study it in the computer science or basically in any direction where the numbers are used or the data is used, then you would probably notice that the tasks are mostly now built not using the formulas, not using the calculations like this way, but using the computer code. And that's true also in my studies. I studied statistics, mathematics and statistics, and there lots of the calculations were replaced by programming algorithms, just because it's much more safe. It's much more safe if we build the program, so we cannot. What's the key advantage here? If we build the program, if we build the algorithm, we have less possibility, probability that we will let some kind of arithmetical mistake, and then we miss something, like the usual problems in mathematics would be that the minus sign is missed, or something like that. Then of course it's much more safe and easy and practical and faster to use the computer program to achieve the results. And also the key point, which may be complicated, but which is what usually the beginners have, is that there is almost such solutions where there's no such problems where there's only one solution. So from the algorithm perspective, usually, and but I would say always, or almost always, there is more than one solution to get to the right place. Again, that's true, and this will always happen. You will find multiple and lots of solutions for your problems, for tasks we have, and also for the tasks we will have in the future. But so when we think about the programming, of course, as I just said, it's true that your program will work, so using different algorithms. But as I stated several times, when you think about the algorithm, you should also, maybe not at the beginning of our course, but when you work with more complicated solutions, then you should also think about the performance of your code. That's just as a simple example would be if you want to get from the hotel to train station, then so there are differences if we go this path, or we go this path. So yes, that's the shortest one. Or if we go like this path. So here, and here. Of course, we will achieve the same result, but we'll spend more time, right? And from the programming perspective, of course, there are many different solutions here how we can go to the train station from our hotel. But of course, there is only one or usually there's only one, maybe in this case there are two. Not really sure if this pass is same as this one, but yeah, in this case you can see we have one or two fastest pass, and of course it's always better to achieve the train station in West Dublin than much it's see to achieve the train station in much more less time than you can do it with the long path. Yeah, but yeah, it also depends maybe on your needs. When you want to have a long walk, then of course this path is the best one. Yeah, if you go here, here, and here. But yeah, in general, there can be the shortest path. You know what I want to say, and this may be the most efficient path to go by. Yeah, so that's what we think about when we create our algorithms. And yeah, how basically can we represent the algorithm? So we provide the steps what should be done. So the easiest way will be simply by text. We simply write please do this, please do that, if this and do that, else if and follow this path, or something like that. So this can be done using natural text. This can be done using computer code. So we write the code, then we can also execute this code and see the result. And yeah, often also for the algorithms we use pseudo codes. What about maybe shortly about the pseudo codes? This is undefined. Language, undefined programming language, where you can just simply, because again, what I said, most of the most popular programming languages are quite similar. Yeah, and that's why when you write pseudocode, you can simply collect everything from all languages you know, then just describe the algorithm using the basic statements used in different programming languages, and basically everyone will understand what do you mean there. And that is what is called as pseudocode. So basically, that would be complicated to describe for the beginners, but just you'll see that if you work with C#, C++, or anything else, then you can write pseudocode, and you do not really care about what language is it. You can just simply use any elements from any language you want, and then you can write pseudocode. It will be understandable by everyone. So that's about text-based approaches, and then we can also have the graphical approach. So this can be map-based. So you define the map with the steps to be gone through during the execution of the algorithm, and also the flow chart. It's quite straightforward. The way how we can describe the steps. And let's move to the example. This is quite simple. Changing the burned white bulb in Desktop. So first of all, we have first step. If we do not have new white bulb, then we go and buy new one. So quite simple. First step. So we have one condition. So if something is in this case we can talk more programming code. So what we have in this case, if you do not have a new white bulb, so this returns true or false. So do we have white bulb? True. Then we do not execute this step. Do we have a new white bulb? False. Then we execute this step. So in this case we can read the statement as operation which returns as true or false. And then based on this operation, if it's true, then we execute this operation. We go next. So here we don't have any statement which returns as true or false, just the action to be done. So turn off the power. action, then then you should twist burn right bulb counter clockwise until we remove it. So yeah, this should be repeated. So here we have what's in theory this is continuous operation. So if you remember what continuous means, so that we do something continuously without stops. But in fact this is, from the program perspective, this should be discrete action. So what does it mean? It means that we have one turn, we have another turn, let's say first turn, second turn, third turn, and then after each turn we check if the white bulb is removed. So in this case we have a cycle, and we'll talk about cycles also in this course. And basically in this case we can also see how the cycles work. So we have the, as I just said, we have the checks. So basically we have the main check if the white bulb is removed. So let's just quickly describe it. Is it removed? No. So we have a statement which returns true or false. If it's false, then we twist the burn white bulb counterclockwise. We do one action. We basically do one action. So that's first iteration of the cycle. One discrete operation. We go next. We check. Is the white bulb removed? No. So that's returns false. Then again we do this operation. We go to the third iteration. Again we check if it is removed. If it returns false. If it returns false, repeat this step. Then let's say at some point this one returns that it is removed, it's true, it's a statement. Logical operation returns true, yeah, it is removed, then we not need to execute this step, yeah, and we move on. So that's these steps. Is it clear how we can imagine from the programming point of view? This is what I just explained. I mean, what I want from you to understand that here we have the cases which return as true or false. And if true, then we have another action, or maybe false, then we have another action, and then if it's true, then we have different action. And so here we have some let's say 2 parts. Yeah, and these are based on the return of the check operation if it's true or false. And then we also have the cycle. When we check some kind of condition, if the condition is achieved, then we move out of the cycle and go next. So the next one is throughout the burned white bulb. So this is one simple action, no any checks, just we execute this operation. Next one is place the new white bulb into the socket. So also the action without any conditions. One condition what we could add here, for example, this would be also interesting for you. A new one. So if all the white bulbs are sold, then break abort the operation. Break the wall operation, for example. Yeah, so that's also one of the part of the algorithms which will execute in the programming code. Yeah, so at some point you can also totally break your algorithm. So that's also possible in programming, and we'll see that actually we can achieve it using the return statement. So, but yeah, this is what we'll do a bit later. So just for the return statement, it means that we simply break the whole program at some point. So that's as an example. Then Yeah, so if we move on with our algorithm, so place an while to the socket pretty straightforward, and then the next operation, which is also the cycle. So what we check? We check the condition. Is it tight? No. Then we turn it clockwise. Again. Next, second iteration of the cycle. Is it true or false? Is false? We continue this one. And then go next. Is this true or false? Say it's false, then we continue here. We execute this operation. Is it false? No, it's true. It's tight. Then we don't execute this one, and then we go next, and then we have another action, which is turn the power on, and the algorithm is finished. So, and right now, I tried to review this one as we would expect it to be done, to be described in the programming code. Yeah. So the key points here is, if we talk about cycles, then we should, basically almost everywhere, we should, not almost everywhere, but in some cases we just have straight actions without any conditions, like this one, and so just turn off the power, like this one, turn on the power, like this one, and just do the action, this one, just do the action. Then we have some conditional actions. So these are the actions which are based on some kind of condition. Like in this case, we have this condition, then true or false. So, and based on the result, if the result is true or the result is false, then we do the next step. Then the next step also can have some kind of nested conditional statement. Like in this case, that we go to the store and we see that all the light bulbs are sold. In this case, what we do, we have no options to do. We simply break this algorithm and maybe wait for tomorrow, for example, as an option. And also for the cycles, again, it means that we return, we repeat the same operations, which are also, as I said, based on the conditional statement, which returns true or false, statement, which is executed after each operation. So this is how we actually see, we as the programmers, how we see the algorithm, and then how we will write it in the program code. So this is how we can describe it, and this is what I said. If 10 conditions, yeah. Then basically some key steps, some key properties of the construction algorithm. So first of all, we should know the sequence. Yeah, otherwise, if there is no sequence, then nothing will work. Yeah, because we cannot shuffle the sequence here and expect some kind of meaningful result. Of course, that's not possible. If, for example, first we turn the power on, then we'll throw off the burned light bulb. Of course, this is not how the algorithm may work. So the algorithm should be step by step. You should have the right sequence, and you should proceed with the sequence provided. Then we have the decisions, and this is what I said. These are the conditional. These are basically conditional operations. They return true or false, and based on the return result, we proceed with one or another path. And this is basically why the booleans are used. That's why we always, why we so usually use booleans. We describe the logical operations using them, and then we provide them. We write the code, which actually calculates the decision. And usually we should also have, should only have, okay, there's also switch statement we'll talk about a little bit later, but for the base way we have, we usually have two ways to go, and mostly we talk about if it's true or false. Again, we'll see what the switch statement is. It means that this is the state which can actually go by more than 2 ways. But again, as I said, in general, in most of the solutions we use two paths, and it's always based on true or false. And then we have repetitions, which we can also call cycles. So it means that the same, highlighted, the same operation is repeated for several times. Again, how many times? Basically, not several times would be correct, but to be more precise, repetitions means that the same operation is executed until some condition is true or false. Again, it's based on, so we can say true, but of course if we want it to be false, then we can simply say not false. So let's say that until one condition is, let's say, true, then the same statement is executed. The same action is executed once one condition is true. And how you build this condition, this can be whatever we want. For example, let's if we want to print the numbers from 1 to 10, for example, then what we can do, we can write the cycle, we can actually say, we can declare the variable, and the variable would start at, let's say, 1, and then we say, please do the repetitions, based on the condition that the variable value is, so repeat if the variable value is less than 11. So just to print values from 1 to 10. So we have the check or logical condition. So variable value is less than 11. Is it true or is it false? If it's true, then we can proceed with the repetitions with the operations. And the first operation will be that we increment this variable by 1. So at the first operation it will be 2. And then we print so first we print the variable value, the value of the variable, and then we print then we increment this variable. So maybe I don't want to show you how we can write the cycles, but this would be that we have a variable, the integer, for example, we can call it iterator, so we start at 1, and then we have the condition, so if iterator is less than 11, or less or equals 10, then build the following actions. So first action would be print iterator, print the value of iterator variable, and then the second would be increment iterator. So this is how the end, of course you can say repeat, say repeat until say repeat while okay, maybe let's say just say repeat, I guess that's correct again. So repeat these two steps once the iterator until the while the iterator is less than 10. So again, we have true or false at this point, then we have the operations here, then we go again here and check if this one is true or false. If it's true, we go next. If it's false, then we finish this statement. We finish this repetition, these repetitions. And also the same way we can describe any process, for example, baking a cake. So we say step-by-step procedure, how should we proceed, what are steps to be done. And this is basically what we call the algorithm. Just to summarize, algorithms describe the procedure of carrying out a task or solving a problem in a step-by-step fashion, which can include sequences, decisions, and iterations. So these are the main things we will be dealing with. And so usually for the algorithm building, you will find such charts, whole charts, where we can where we'll see the path and the algorithm. So as always, we have the start, then we have some kind of decision. So is the power off? No. Then we go here, power is off. Then we go here, and so we have one more step that the power is on. And so we go this way. Then yeah. So here again we have the decision. And do we have the poison ball? We go here. Then we go to the white ball store and buy a new one. And then we return home. So we go here. So and again, if we do have, then we skip these steps and we go here. And again we have the decision. So if I cannot reach, then I need to get a chair, then I place down the path, and I again I tap the path with the fingers. So it's quite straightforward. We have the path, and our path is how do we actually go is based on the decision making during the algorithm. Yeah. So at this point we don't use any repetitions, just decisions and of course the sequence. Yeah. So we start here, we cannot start from here, we can start from here. Yes, that makes sense. Yeah. Also, another example would be that you have some more advanced structure. I also have direction, please note. So in this case it cannot be actually here we can see the repetitions. So we can go this way, and then we can go back here. Oh no, we cannot go back here, sorry. No, at this point yeah, we don't have the repetitions, but so the path here is more advanced. But yeah, in fact, there may be some repetitions. For example, if you could go from one step to a step back, these to be called as the repetitions. Then about the correctness of the algorithm. So we say that the algorithm is correct if for every input instance it outputs the correct output. Then, so the point for the algorithm is that if we have, that's basically the same as in mathematics. You know that in mathematics we have the functions, right? So this means that we put some parameters to the function and the variables to the function, and the function returns us the result. And by the definition of the function for each parameter, for every parameter provided, or any set of parameters provided, there can be only one result. Yeah, you cannot have two different results if you provide the same parameters. That's not possible. Same for the algorithm. If you provide the same parameter to the algorithm, you will have the same result. That's obviously. So you cannot have, it cannot be something random. No, of course it can be random, but that happens only based on the if there are some random algorithms used inside. But this is maybe more advanced case, and this is also correct case because the result will be correct anyways, because you expect the random result. But yeah, that's maybe a little bit different case. And we say that the correct algorithm solves the given computational problem. That's for sure, yeah, it cannot do anything else but to solve the problem. Then incorrect algorithm might not help at all on some input instances, or might help with an incorrect answer, so that's also quite straightforward. Contrary to what you might expect, incorrect algorithms can sometimes be useful if we can control their error rate. Yeah, that's may also be true if the algorithms are quite complicated. Then sometimes we should use them. For example, if you use statistics, then basically in statistics we cannot really say that all the algorithms are 100% correct. In statistics you have the probability, and then the probability rate, and of course based on the probability rate we may accept or decline the result we get. And that's why for the statistical programs, then there might be some levels of what we can, some levels of errors we can actually accept. So that's as an option. And yeah, so, but at the beginning, and in most cases, we will consider only the correct algorithms, without errors, because other test algorithms will be more complicated at this point. Okay, and yeah, short description what are the differences between the algorithms. Zeta-Cost algorithm, that's more abstract definition of what we actually write. Again, as I said, it can be the text, it can be the flow chart or something like that, which basically describes the process, yeah, in general. But the fact that this is not what we can directly and straightforward transport to the programming code. But on the other hand, we use Zeta code, and Zeta code that's not actually, as I said, that's not actually a real programming code, but this is the concept of the programming code. Yeah, for example, this is what I written here. This is, I would say, some kind of Zeta code. Yeah, this is not the actual code I can write in C#, for example, but this is the I actually described all the steps here, which I can just directly translate. One by one, I can translate them into the programming language. So that is what Zeta code is. Yeah. So and at last, let's talk about the design. And basically, it should be called creating a robust algorithm to solve a problem in an efficient way using minimal time and space. Yeah, this is what I said. This is what we have to achieve in the programming. We should think about the performance. And when we talk about performance, and maybe if you study or studying or study it, or if you will study computer science, most likely you have the courses about the algorithms, and these courses are based on, the efficiency of the algorithms is based on two components. Yeah, basically we usually are not interested in other components but time and space. Yeah, so time, it means how fast our algorithm is, and so how quickly we can achieve the result, and in space, how many space does it take. Yeah, so the quick example and the easy example from the real life would be, for example, I want to, let's say, I live outside from Riga, so, and for example, I want to get to the city center, Riga center, so I have several options. The first option would be that I take the car and let's drive to the center. So in this case, I will spend less time, but I will actually use more space. And in this case, we can consider the space as, for example, the cost. It will be more expensive. And also if you think about the environment, okay, let's keep the environment. Let's just simply say that this will be more expensive. But on the other hand, if I use the bus, for example, then that will require me more time. However, on the other hand, I will spend less money there. So that's an assumption. For the programming, again, we have the time and memory. So how fast the algorithm is. So for example, we can use thousands of variables, and in this case that some algorithm may be faster, but we need to declare all these variables, we need to declare space for them, and in this case it will require more space. And maybe the best, not best, but so really nice example would be that we had in our first, let's quickly open this presentation from the first session. That was Intro in IT, and I talked about the application server. So for example, we can use the approach when we directly access the database. So this would take more time, because every time we want to access the database, this is quite long process. I mean, not quite long, but relatively it takes some time. But in this case, we don't need additional space, because everything is stored on the database. On the other hand, we can use application server, so we need more space, because we need to place the data there, and so of course this takes more space. But on the other hand, it's faster to take the data from there, and this takes less time. So that's basically the same. This way it works for most of the algorithms. Just for your information, in our course we will only take a look on the time, from the time perspective, and we will maybe not talk about space, because from my experience, usually for the algorithms I work on, I only think about time. However, sometimes, there were some cases where I had where the memory limits were expired. Just maybe I can quickly also tell you this example when I had this. So there was the system where I had to implement the search. So we have database with some kind of data, and then I had to implement the search. Actually, the search was implemented before me. I just had to add an additional search parameter for the data search. Like for example, we have some kind of data, and the data has the parameters, and then I had to actually add one more parameter there. And what actually was wrong with that search? The program was built in the way that it takes so many data from the database, just simply reads it inside the code. So the space was overloaded, and the program just crashed there. So that program was not built by me, but I was working with such program where it was the actual problems with the spaces, mostly the issue may be not because of the data declarations, but because of the. So if you work with the data from the database, on practice you may have millions. You may actually work with millions, not you, but your program may actually work with millions of entries from the database there, and if you read all these entries, or you read part of these entries in your code, so for example, in this case, you will have everything stored inside your program, then Of course, this may trigger some errors related to the memory. Yeah, and sometimes that's maybe a trade-off. So what I said. And so here you can see steps. So in the computation process, first of all, we generally need to define what we want to achieve, then develop the model, then specify the algorithm, design it, check if it's correct or not. If not, then again go back and do some changes there, then analyze how efficient it is, how it works, if all the requirements are achieved here, then implement it, test it again, and document so that the algorithm and the task is done. Okay, then so let's say we have the break now, and during the break, so you can think about how can we write the algorithm to sort a hand of cards. I mean, just simply by numbers. And so you have the cards in your hand, and you just need to sort it from the lowest number to from the card with the lowest number to the card with the highest number. And how you can achieve it. And so you can think about it during the break, and after the break I will write the algorithm how this can be done. Okay? Let's have 10 minutes. So let's continue, and so how the algorithm will look like. So let's say that we have an unknown number of the cards in our hand. So let's say that we have the number of the cards. So that's kind of number, let's say that we have 10 cards. And this is what we can detect. And then what we need to do. Maybe I would explain it this way. So the idea is that we go through, so first we start at the first card. We need to go through all the cards. So let's take the first card. So we take the first card, then we go one by one on the right side. Okay, so let's start from left, then we go to right. So we check the card with the next one. So we take the next one, and then we check if the next one is greater than the one we checked. If it's true, then then we take. Then we stop at this point. We go back. We go to the second card. We take the second card. Then we check the pairs. So, and one by one. So we go from left to right. So we'll check if it's greater, not, then it stays here. Take the next one, greater, not, stays here. If it is greater, if it is greater than the next one, then we swap them. Then we go next again. Then we do the same operation. If the current card is greater than the next one, we swap it. If not, then we keep as it is and we check the next one. So this way we should check all the cards, and this is actually the concept of bubble sort. We'll talk about bubble sort a little bit later, but I can show you that I will just simply share you the link in Wikipedia. So this is basically the algorithm of bubble sort, which is what they describe. Simply go through all the cards from left side to right and check if the current card is greater than the next one, then swap. If not, then so keep it as is and go to the next card from the beginning. And once we reach the last card, then everything should be sorted correctly. So as an option, actually there are lots of sorting options, and there are lots of sorting algorithms, and we'll take a look at them a little bit later. So there is no one solution, and actually you'll also see that there are different algorithms built for the sorting, and there are differences between them. Some of them are faster, some of them are smaller, some of them require more memory, and also some of them work differently based on the different data we actually need to sort. Yeah, we'll take a look on them a little bit later in our course. So, for the algorithms, that's it. Do you have any questions maybe? So if not, then I can, so maybe let me describe the practical assignment for the algorithms. So in this assignment we will have 3 tasks, and so the first task will be that you need to bake cake, and so then just simply describe the algorithm. That's actually it is here, so you don't need to do anything. The algorithm is already in place. That's just to get it pointed with. Then we go to the next one. This is what you actually need to do. So first you have the information, and then you just need to describe it after that. Regarding the flow chart, so maybe I guess maybe some links will not work. So this one, okay, this one does not work, and okay, yeah. So now we have the templates. Actually, you can select any of them. Maybe you can build this one and then use this template, for example. Yeah, but you simply go here and select one of the templates. So I'm not sure this will come with the tasks. But that's up to you what to select here. And yeah, so we can also take another example, but yeah, so from these two you can select just up to you. Yeah. To you what kind of chart to use. And then also a little bit for the mathematical point of view. So this you can also create using flowchart. Again, you can select it, so what you want to do from here, from the templates. Can be any template you want to use, and then using this template, simply explain step by step how to solve what is larger and so what of these is larger, and then also for the equation, please describe the algorithm step by step how to solve. Okay. So do you have any questions about home task? Regarding the deadline will be I would say so just about to run. Maybe let's what it be? It would be the next not the next Monday, but the Monday the week after next. So that will be 26th of July. That's quite, I would say, not complicated assignment. So, but it's no hurry. You can finish it. I would say quite quickly, but be there 26th of July. And yeah, so how you should, maybe you will have the question how, the question from why do you just confirm we don't have to put anything? Simply write this as the first text and then make the flow chart. Yeah, you don't need to write the code here, just as the text here. So as the flow chart. As the flow chart, and then how to share it with me. Quite simply, just create the flow chart, save it as you want. You can save it as the image, for example, as the picture, screenshot, and then put the screenshot in your repository, and then push it to your remote repository. So I'll check all your home tasks just directly from your repository. What you shared with me, or what you will share with me for the first practical assignment we had for the Git. For Git, you should share your repositories with me. So this will be the actual repository where you will just share all the practical assignments. If you want, you can also create a new repository and share it with me. That's up to you, but just to make it easier for me, and I guess for you as well, just not create multiple repositories. It's easier to keep everything inside one repository. Yeah, that's up to you. What's the best option? But again, I said better to put everything inside one remote repository. Okay, and now we can finally move to the topic, which will actually allow us to implement meaningful algorithms in C#. And yeah, this is about branching. The branching, and so first of all, what we need to think about. As you remember, so during the previous sessions, we wrote the code, and our code simply worked in the quite straightforward way. Just execute the actions one by one. Yeah? So execute this one, right line, then execute this one, and so on. Yeah? So just simply we do step by step, and the only thing we do is that we execute the functions, the commands in direct way, just one by one, without any conditions, without any different paths. There's only one path how the program works. So just one direct path without any conditions. Yeah. So this is what we've done until now, and we can call it as linear control for. So everything happens linearly. Just put charger into my headphones. 10 seconds. Okay. Okay, so the charger is on. Okay. So, yeah, previously we only worked in the linear way. Just simple direct execution of the commands. But in fact, this is not how we can build the meaningful algorithm. So let me double check if my sound is still in place. Oh yeah, one moment, I need to set up my headphones because I see that they're disconnected. Maybe the sound will not be greatest one for now. One moment. Okay, I guess that should be fine. One moment, I will. Okay. Okay, I guess right now it should be a little bit better. Yes, right. So okay, my sound is now was back, I guess. So yeah, so let's continue. So yeah, about the control flow. I mean, to implement any meaningful algorithm, as we've seen from the previous presentation, we need to have some decisions. Okay, first of all, we need to have the decisions, also we need to have the cycles, the repetitions, and it's obviously that we cannot do it by simply using such a way of coding when everything just goes straightforward way, yeah, without any decisions or without any repetitions. So sometimes there may be more actions we have not worked with yet. So for example, the program can be stopped at some point. Yeah, so it means that, let's say that based on some conditions we can stop the command at this point or at this point. Or if there are any errors or the incorrect input was somewhere here, for example, then the program can be stopped. Yeah, also for example in this case what we can see it is then actually automatically but operations see. So let's say if we enter the value as something which is not numerical, then the program actually will be stopped. Yeah? So in this case, it's something more special than just direct step-by-step execution. And so at some point, the program may be stopped. So this will be one of the points of the branching. Then another one. This can be the jump to some other line of code. About the unconditional, that's quite interesting maybe thing. This is quite, I would say not a straightforward point. We'll maybe talk about this a little bit later. This is also related to go-to statement, which nowadays is mostly escaped by the programmers, and we'll see why. But yeah, also can be conditional jump based on some kind of conditions, like based on decisions actually. Then also jump ahead skipping some kind of code also can be done. For example, we say, as we had in the algorithm about the whiteboard, so if we don't have new whiteboard, then we go to the store and buy them. And buy the whiteboard. Okay. So then we can also jump ahead, selecting one of several possible lines of code to execute based on our defined condition. And so that's also part of the branching. Then we can jump back to repeat the block of code. That's the looping. And the looping is also actually based on the condition. So I said it should be something which is based on the return of the check which returns true or false. Yeah. Usually it happens in a way that the block is repeated if the condition is true. But you can find it should always be true, you have to repeat. But how you define this condition, that's up to you. And then there can be the functions, keep the thing organized. That means that you can conditional jump to some other block of code only to return at the later point in the time. So that's about the functions. We will talk about them a little bit later and see how the actual function works. So define the block of calls. So as I mentioned before, we can use curly brackets to actually define the start and the end of some kind of block of the code. Usually it will be the class, the method, or class, the method, the structure, or something similar. It can contain almost any code you want, so that's true. Changes to the control folder in fact block of code. So it means that we start at some point and finish at some point here. And why we basically use this? We use this to group our code, to organize it in a way that again, if we use the branching, then we talk about the code parts to be or to not be executed. And the block of course to be skipped. So this is the way how we can define the block which will be executed or not executed based on some conditions. So that's why we will use curly brackets. And why we use brackets of the semicolon, because we have multiple. Again, using the semicolon, we close the operation. Statement. If something happens, we use semicolon. But in this case, we have multiple things to happen. That's why we combine them inside the block, and we define this block using curly brackets. And how the branching logic looks like. So you may already seen somewhere that for the programming there's if statement used. So that's the simple way. So we have some kind of actions before, and then at this point we have if statement. how if statements are built. So on this we have if keyword, and then we have the rounded brackets. Inside the rounded brackets we can actually see the statement, logical statement, which returns true or false. And this is exactly, so if we take a look at the construction of the if statements, that this is what I said before. We should consider all the checks, all the decisions, all the decisions from the perspective that they return true or false. And based on the result, if the result is true or false, we will go one or another way. And this is how we should always consider the if statements. If statements will have the set the logical operation returns true or false, and what happens here if this logical operation, what's inside the round brackets, I don't care what is inside, I'm only interested in the returning result of what's inside the round brackets, if it's true or false. Then what happens next? If the result is true, this block is executed. If the result is false, this block is not executed. That's how the construction of the if works. We'll see that if also has else if and else additions to the statement in general, but initially what you can see here, construction is similar. If it's simple, if then the conditional statement, true or false, if true, block is executed, otherwise block is not executed. So quite straightforward. Okay, so it's here, block is skipped otherwise. Then we also have else. Else keyword, else addition to the if statement, and this is actually the addition of the statement. In theory, we can define the same code as something like this. So, so this way it will be the same if we have the opposite of this one. So if we type the opposite one of the if statement, this will be the same as we simply type else. Yeah. So if we say else, then this means the same as else. This means the same as we have another block which takes the opposite of the previous if statement. But in general, yeah, it works the way that we can check if it's true or false. If it's true, it goes to this statement and execute to this block and executes it. Otherwise, it goes to this block and then this block is executed. So just simple from the English, if else, if something is if true, this block, if false, then it's else and it goes to this block. So straightforward, I guess, right? So any questions about if statement, please let me know. We'll also see that there are else if statement, but yeah, so using if statement we can skip a block of code based on some conditions. So do it. Use if statement, that's the result keyword, as I already mentioned, and the values true or false. If true, block is executed. If false, it goes to else block if it is defined, or it simply skips if block if it's if else is not defined, and then it just goes next. So about the construction of if statements. So as a mandatory thing there, you should write if. So if condition true or false, and the block of code. Or okay, or is the exceptions rule. talk about it a bit later. And in addition to this if, you can add the else block. So that's optional one. You can define else block, or you can skip defining else block. That is no difference, it's up to you, up to the algorithm you want to implement. So else is optional for if statements. So this is how general looks like. And scalable code for if the condition is false. But again, condition is something that becomes true or false. In theory, you can simply say, if true, then this block will always be executed. Or if false, then this block will never be executed. So the program just simply understands the boolean value true or false. Well, yeah. So then use else. And this is what I said. If we have one option or another or something else, then we use if else. Yeah. Also, everything is based on an if statement, and if the condition returns true, then if is executed. If the condition returns false, then else is executed. Yeah. And after that, after the if statement, the flow actually merges again, and the code continues its work. Yeah. In natural language, we would say that if the condition is true, then do block 1, otherwise do block 2, then so that's the syntax. And if condition true false, then block, then else, second block, and code after it. So maybe we can and we'll show you how to implement it, how to implement something. So let's say call this file as the branching. So then I find the same signature, so the namespace of the let it be okay, there's some branching and rebranching. And so that's then with simple thing. So for example, let's ask the user to enter the age. So let's read the input from console. Yeah, first of all, let's maybe also ask the user to write the age. What's your age? And how old are you? It's up to you what to write here. So, and then here we check if age is less than 18, then, so let's say, if age is less than 18, then we print the following thing. You can't buy this glass of beer. Else we can print. So we can print, for example, what beer you would prefer. Yeah, so something like that. As an option, and here we can compile this code. Let's just hit CS. Sorry. Symbol branchings. Branching. This same images. 19, and it asks me what they are after. So then, if I say that my age is 10, then this block is activated. Yeah? So quite straightforward. If this is true, then if this is false, then this is activated. So quite simple. In addition, there is one thing I will explain you now. So let's compile the code. And let's execute the code. So then, the program this will work the same way. That's what happens here. I keep using the curly brackets, and maybe unfortunately for some of you, I will sometimes keep using the curly brackets. And actually, when I can skip using them, I can skip using curly brackets if I have only one statement. Okay, so like in this case, I have only one statement, then I can skip using curly brackets. If I have more than one statement, then this will be incorrect. Yeah, because I have more than one statement. So if you have only one statement under if or else, then you can skip using the curly brackets, because the program will understand that basically how it will read. It reads this: if age is 18, then do this step. So C semicolon, and then it closes this if statement. But if you have multiple statements, it cannot actually really understand, and the compiler cannot actually really understand at which point the if statement is, if block is closed. Yeah? So that's why maybe I'll add the brackets, and then I will write the comment that this is the same as if we use curly brackets. So so if we have only one action to be executed under if or else statements, then we can keep using curly brackets. So that's about if else structure. Quite straightforward, I would say. Do you have any questions about the main concept of usage for if else? Okay, question what will happen if someone will answer with selector or with that's actually the exception case. And this actually we can do it, and I will show you then really quickly what will happen here. Branching tokens. So it's going here. Branching tokens. Okay. So if answer what, we'll see the exception. We'll see the exception, the program will be terminated. And from where this exception comes? This exception actually comes from this place. We will, in our course, we will talk about the exceptions. Let me show the structure of the course. This will be Well, that was not initially included, I guess, but at some point we will definitely go through the concept more with exceptions, because this is the base for all the programming languages. But the simple idea is that at this point the program will actually end. So if you ask what will happen, the program will actually be terminated, and basically it will be terminated from this place, from this method execution, because parsing can only be done for the integers. In theory, I will show you try catch, and maybe I will not explain you the concept of try catch, because this will be the next, not the next, but one of the next topics. But actually, then quickly can show you how we can proceed in such case. So one moment, we have a handle exception. Default exception. Again, maybe for you this is a little bit confusing how try catches are used, but just maybe I'll quickly show you, and in case maybe you want to also use it in your further code, then I'll say right line and say only integer numbers can be entered. And maybe also you can close the code. So yeah, maybe a little bit confusing, but that's just as the notion of what we can do here. So let's maybe compile this. Go to okay, hold on. Yeah, there's also one interesting. Yeah, maybe this point is actually relevant, because this is what I said. When we define the variable inside the block, then the variable will not be available outside the block. For example, if we have this block here again, I will not tell you about try catch, how this concept works, but the concept of the brackets remains the same in all the scenarios. If we have the variable age defined under this block, so we have this start and this end, then it cannot be visible outside this block. So that's why what we can do, define, so the easiest approach would be that we define variable outside the block, and then we execute it, and then we send value inside the block. So we compile it. We see the variable e, but that's not so important right now, and let's see what will happen there. So now I will enter something like this, and I see the output. Just without the deep explanation, how try catch works. Basically, we have the code inside try, then it catches the special exception. So in this case, that was, as I can see from the console line, the exception was, we see a handled exception showing that this exception was called, was handled. So I use this exception here. I say that please catch this exception once this part of the code is executed. And then if this exception is handled, what we can see here, then this block is executed and return actually breaks the program. So maybe we'll talk about the try catch concept a little bit later, but since you asked about what will happen and how we can maybe handle this, so basically the only way, actually we can make also easier way. So this would be the standard approach and you will use once you know the concept of try catch. Another option would be, I will show you, and also maybe the question from Christine, how many if and else can go under one integer. So integer is not located under if. It's just simply used as the statement. So in theory, you can say you can use many statements here, or age something like this, yeah, or just you can combine many statements here. But the idea of age is that's simply integer. That's the variable. You can use it as all the variables, and in this case, if and else they do not go under one integer. In this case, that's simply variable. And that's variable. We can add multiple checks. Like we have one check, we can have another check. For example, if age is greater than 21, so for example, we can say that about the alcohol rules, you can buy. So if age is greater than 21, you can say you can buy this. Sure. Maybe whiskey. Those are not specialists in alcohol. And then we can say you are too young to buy whiskey. And so we can use it multiple times as we want. So that's the variable. We can use it as we want. In this case, we are not restricted with how many times we reuse anything. Yeah. So just information, no restrictions in programming. Variables can be used as many times as we want. Yeah. And also, yeah, we'll see later that we can also use nested ifs. So if inside if, so we go if here, and we go inside this box. So inside this box, we may also have multiple if else statements. And maybe to make same approach as we just to make the same result as we just had here with try catch, we can do it in more understandable language for you, and this will look this way. So we can define the string text age. So then we can read. So first of all, at this point, we just simply read the text. So at this point, the value from the console will be read as the text. So value from the console is read as the text. Then the next step would be that we also check, we can add our additional exception handling and check if the value contains any non-strings. Let's say if the value contains any text characters, then any non-integer characters, then this will be incorrect. So what we can do, we can actually and we can use the method can actually check the return. Check if string contains, so there should be contains method. Yeah, contains. And so here we can check if string contains non-integers or non-numericals. So for this case, we can actually use I think there are multiple ways how we can do multiple ways. One moment. Oh, actually no, there's better option. There's better option. We can use integer class And here we can use try parse. Try parse. And so what will be done here? Try parse, and then we say from where we want to parse. Be text age, and this would be it. So let's double check. Parse, yeah. Yeah, that's true or false. True or false. Yeah. So I'll try to parse integer to false. Yeah. So this is how this will look like. And then we can say that's only integers. Simply copy paste this part of the code, and then I'll comment it. So let's see how does this work. Yeah, okay. So it's punching. Okay. Oh, yeah, also out is needed, so yeah, maybe about this. Then we'll explain a little bit later. Okay, so now this will basically work the same way as this will work with try catch. So in this case, we add the additional check if actually, yeah. So this is the method which returns true or false. True or false, and here what we say. We say please check, please try to parse the text of the age, so that's the text provided here, to the age, which is integer. So let's already compiled, so it didn't need to but anyway. So if we say something like this, then yeah. So now it works as expected. So yeah, basically in this case what happens is it tries to parse text to integer. So if everything is fine and the text can be parsed to integer, then it actually parses it to integer, we get age. So that's the result. And we'll have the value here. Otherwise, so it actually returns also true. In addition, it returns true or false. So if this returns true, that means that it can parse, and then the statement will be not true, which is false. So in this case, if block will not be executed. Yeah. Otherwise, if there's text inside the integer number, then it cannot parse it, so this will be false, and not false equals true. So this block then will be executed. Okay, and yeah, return means that we simply break the program. Break the program. Okay, I understand maybe some things may be a little bit confusing for you, especially if this out, but yeah, this is quite a specific thing for C#. This means that we'll later on check this keyword. Also, we'll maybe use return a little bit later. Try catch again. Definitely we'll talk about the exceptions later on. But for now, what we need to see, we need to see how if. The key thing for us is to see how if and if else blocks work for us. So, but yeah, any questions maybe about this one you can ask me, also ask me during the break. But for now, let's maybe have 10 minutes break, and after that we will continue with the branching. Okay, let's move on. So that's about the general structure of if-else statement. Okay, see something, questions. Questions are always welcomed. Yeah, learning statements. Okay, so you can see that the questions are coming, so maybe we can wait for the questions. Then can yeah, for me, I don't understand what does that part mean. H is name, which that part? Say this part, that part. Yeah, for my maybe I would start on it. I don't understand what does that part mean. H is name of integers, so alt H. Alt H, that's actually the specific thing of C#. So that's because so in fact we'll later on see that all the methods have the returning they may have the returning parameters, so they mean that it means that they return something. Like in this case, this method returns the integer number, so it takes the string and this method returns boolean, as you can see from the signature, so it returns true or false if we can parse or not. So this expression returns true or false, and based on the result, if we can parse this text to integer or if we can't parse. So based on the result, it returns true or false. In addition, what can be done? It also returns the additional results. So in this case, we also get the result for H, which also comes from this method. So we actually get the value for age. When this method is executed, the English value from the parsing result. So here we get the result of the parsing, but in general we check if the parsing can be done. So if the parsing cannot be done, so this will be false. Yeah, and the value here, this will be 0 or won't be at all. And so just the check. Means not an integer, but is that text age and text age. Text age. This is simply the text what we can read constant. Here we can make it shorter. As I said, we can simply do it this way. So this would be the same. Yeah? I just don't use the variable in this way. Okay. So that returns the read from console. Okay. So and so that's just that issue. Okay? You can put the result what you read from the console under the variable. Okay. But in fact you can also skip creating the variable and just simply pass it to for Win that's quite simple. Out means what should be returned. We will talk in details about the structure of the methods a little bit later, but in general out means that this is the output parameter. So what will be returned from the method. So that's correct. In fact, that's maybe not really the output. I mean, in this case, we can consider this as the returning parameter. This will be correct. In fact, you will see that this is so-called thing like passing by value and passing by reference. In this case, we pass it by reference, and this is quite a juicy, I would say, juicy thing, which comes from C++ and actually C languages. This is mostly related to the method calls and to the parameters which can be passed to the methods. So at this point, it's real from my point of view. This is a really interesting topic when we talk about pass by value and pass by reference, we'll discuss it a little bit later when we talk about the methods and the parameters used for the methods. Yeah, from the theory point of view, we can say that this is it means pass by reference. Pass by reference, and we get in simple words, this would be that we pass the variable and the method can assign any values to this variable, because by default, if we pass the value, like in this case, we just simply pass the value, so we cannot assign anything to this value. The value will be there and nothing more. But if we use pass by reference, like in this case, it means that we pass we generally pass the variable inside this method. So this variable can also be changed inside this method. So that's from the theory point of view about the pass by reference. We'll discuss it later, but for now, yes, that's correct. We can just simply use it as something what can be returned from the method, and this is actually true, yes. It's actually true. So this is how we can from theory it is called pass by reference. Pass by reference. We'll discuss it a little bit later then. But that should be as the output, so that's the returning parameter. But we'll discuss it once we discuss methods. In this case, we can just simply use it as it is. And for Sabian, what language version of .NET I use? I downloaded the latest version of .NET, so I guess then this should be, I guess, 9.0 if I'm not mistaken. So check in a moment. So maybe just to double check. Let me just double check we can do the following thing. So maybe we can quickly check it using the program. But I remember I downloaded the latest one, so it should be the .NET 5. At this point, I mean, for the tasks we'll work on now, there's no. Sorry, it seems that's fifth version. Okay. Okay, so that's the fourth version. It's not the fifth one. That's interesting. Let's yeah, I'll find. So one moment. Let's check it again. But yeah, I guess that one should be .NET.5. So that should be the. Let's do it again. So that's the version 4.0.3, so it means that this is actually, yeah, that means that's the fourth version. So then it means that this is the C#. Yeah, I guess that's interesting because I thought that I downloaded the latest one. Okay, then maybe I'll check it later because in this computer I did not use C# exactly on this computer, so I downloaded it before first, but I will double check. But then it should be, that's the 4th version. You can check it using this code. I will also share it with you. So check the version of .NET framework. But yeah, I would then maybe double check a little bit why I did not actually start the last one. Yeah. So, but yeah, thank you for clarification. I really thought that I used the last one. But yeah, I maybe see that. Okay, I will double check then a little bit later. At least, I mean, for our purposes, it's maybe not. It's maybe not so really important for now, because I mean, for our purposes, for these topics we'll go through now, the fourth version should be definitely fourth version is definitely fine for us. Okay, so yeah, maybe more questions. Questions about just here. Then if not, we can move on with the branching then. So maybe also one more quick thing. Let me clarify. 10 seconds. So let's checking the download folder, because I'll show that I have the fifth version of .NET. So that's a moment. .NET. Agreement. Okay, then I'll double check a little bit later. Okay, so but right now let's move on to the condition. Yeah, this is basically a small recap of what we discussed before. So as you know, anything. So we actually conclude the decision if it goes one or another way using true or false. We determine if the program determines if the code should go one or another way using the conditions which return true or false. But yeah, this is what I already said. Every time we check something, so like if it's age greater than 21 or just anything else what returns true or false, at the end you get true or false, and then the statement is executed. Yeah, so that's based on the result. If true, we go under if false, then we go under else, or if else is not defined, then simply skip it. Then, yeah, so logical expressions, what we can actually use. As you remember previously, we can use logical expressions. We can use the operators to check, to actually get the results true or false. So, and as you remember, we can compare two variables or two values, and then can get the result true or false. Again, we can check if they are equal. We can also check if something should be greater or less than something. In all these cases, what I said in general, we have the return result which is true or false. So that's a key point. Also, we can use not operator in some cases. That's what I did here. So in this case, I wanted to actually check if this statement returns false. Yeah, so if it tries to parse, then the try is unsuccessful, then this will be false. But what I know that I can reach this if block only if condition is true. So to achieve that this one is true, I need to get the opposite of this one. Yeah. So this means if try parse fails, then this should be false. Yeah. So it cannot be parsed. But if I add not statement, then I actually get the opposite result, which means that if this is false, then actually the whole statement will be true, and it goes under if statement. Alright, so then we can also combine multiple conditions, like let's say we can maybe add something more. So let's say we can ask what is the drink you prefer? So we can comment out this one. What's the drink you prefer? So then I can say, so I will get first of all the name of the drink. That would be drink name, and this would be provided by the user. So it's read line, and the user will provide us the name of the drink. So, and then I ask if sample drink is to be better, I will use equals if drink equals to beer, or maybe let's say like whiskey, if this is true, and let's say maybe the age is, say, less than 21, then we say that you can buy whiskey. So we use and, we check two conditions. So if the user selects whiskey and the age of the user is less than 21, then that's not possible because the user is too young. Then we can actually, maybe we'll talk about it sort of a bit later, but this will be else if. And in this case, I will later on explain how else if works. So if we say if whiskey is selected, then the age is greater or equals to 21, then say, please take your drink. Where else we can say that, just the simple answer, that we don't have such drink. So, what will happen here? Here we will first compile the program and let's see what will happen. Drink name, of course. Okay. Yeah, thank you, Anastasia, this is what I just noticed. Yeah, thank you. So and then that was, actually I also just noticed because of that. Yeah. Thank you, Anastasia. That's correct. Then we have branching. Let's see, yes, everything is fine. And then, so I say the age is, say, 15. Then I prefer whiskey, but I can, unfortunately, I cannot buy the whiskey because I'm too young. It's no point. Then we can say that my age is 29, for example. Then I prefer water, but in this case, what happens here? First it checks, is the name of the drink whiskey? No, so in this case it's not true because the first part is not true. So it checks next. Again, it also checks if the name is whiskey. That's false. Then it goes to the else statement. Yeah. So that's why here we come to the else statement. But what's the key point? The key point here I wanted to show is that we can use and or and we can also use or. And for example, we can say that. So for example, or. Maybe we'll talk. We'll find some. I'll define more examples. Provide more examples a little bit later, please. Or. But yeah, we can use and to actually work with multiple statements. And again, if we use and, it means that both sides should result into true. So that's the same about or, but what we talked about or is that one or another part should be true to get true at the result. So here we just simply do everything what we talked about for logical expressions. We'll have more examples a little bit later. Then what can also happen next? There may be nesting and chaining. And what does it mean? It means that actually one part of the code, one block can be the part of another if-else block. And what will happen in this case? In this case, actually for Go. Basically, in this case, some of the cases described in this presentation will happen. Like in this case, you can see that we actually have if. So let's say we have if, then it's true, and it's here. Then, okay, in this case, no, I mean this is the best one. So we have if, then we don't insert another statement. Then, okay, here we also have true or false. Then this if is actually the part of this if statement, else statement. So, and how can we implement it? Easily, just simply put if inside if. So, for example, how this would look like. So we can a little bit adjust this program. I will comment it out. And then first we say if drink name equals whiskey, then I actually check the age. So if it's whiskey, then I can need to check the age. So if age is, so I have one if statement under another if statement. So then I check if age is less than 21, then I will print sorry, you are too young to buy whiskey. Else, please take it, for example. Okay, so, and yeah, here I have this main if statement, and under this main if statement I have also some nested if, like this case I have one, I can also have more if needed, but then I can say else I can just simply say please take a drink, and I don't check the age. And so, and as I said, if only one statement is used, then we can skip using curly brackets, and in fact in this case we can also skip using them. Why? Because actually the program sees the end of this if block. So I mean, of course, to make it more understandable maybe for you, I can keep the brackets here, but in theory we can also skip using them here, because there's actually only one statement here. That's maybe not so obviously to understand, but in fact it means that if something, then I go next. Here I have if something, so no statement executed yet, and then it will go, my branch will go here, and then we have only one statement. So here we have only one statement. That's why the brackets are not needed, because actually only one statement will be executed. We have no left blocks here. So that's why we can keep using the curly brackets here. But that's up to you. If you want, you can keep that. That's not a mistake, just another option how we can proceed. So the age, let's say 32, say whiskey, and I can take my drink. So I can execute it again. Let's manage stuff, I want to buy whiskey. That's not possible. Then I execute it again. Let's say that now I choose stop, but I want to buy 14, but I want to buy water. So then I can buy water. Yeah, so this is nested if statement included inside another if. Yeah. So if this is true, then this part is, then it goes here, and then of course we can also create more if statements if needed. So that would be the example again. So we have if, then we have another if, and then we can do something inside if statement. So we can put, you can also put the code here, of course, because this is the wall block, and inside it works independently now from the block from where it comes. So there is no dependency there. Then, I mean, for all the blocks, you can simply write any code inside because there are no serious restrictions. There are some, especially about the visibility of the variables, but this is what we will discuss a little bit later. For now, we can just simply write the code for nested if statements. Yeah. So, and you can also put another if under else block. Why not? There are no any restrictions. Yeah. So everything is based under your logic. But to put else if, if you want to put something but to put if statements under else, there you might consider using another option. And this would be else if, what I used before. So how this works, it's simple. I mean, we have if statement. If this statement is not true, then it goes checks another if statement. Yeah, so this in this case, this would be like you want to buy, let's say, the white bulb, as we have it here, for example, for the white bulb. Where was it? Here. Yeah. So you go and go to the store, check if there are the white bulbs in the store. Yeah, so, for example, you check multiple stores. You go to the first store, you check, is there the white bulb? Yes, you buy it, you exit, and you are not searching more. But you can have such a situation when you go to the first store, then you're searching, you don't find, so then you don't buy, you go to the next store. So this would be else if. So if white bulb exists in first store, buy it in first store. If it does not exist, I mean if it's out of stock, for example, or just simply there are no white bulbs in the first store, then you go to the second store, and then you repeat the same operation. And this would be else if, and you go through all the stores until you find the white bulb. So this would be else if, but at the end you might go to such a situation when you actually go through all the possible stores and you don't find the white bulb. So in this case, that would be if, else if, else if, else if. You go through all the stores. At the end, you find nothing. So this would be case else. Yeah, so if you don't find them, you maybe consider some other options. That would be else if, then else if, else if, else if, and else at the end as the default option. So this is how it looks like, for example. So we can check the age, then we see, we can check if the age is less than 5. So if true, then this block is executed and these blocks are not executed. Yeah. So if we have, then we go to this case. First we check this case. Yeah, we check the cases one by one. Check this one. If it's false, we go here, check this one. If it's true, this one is executed. We skip all the checks below. If this is false, then we check the next one. If the next one again is true, this is executed, others skip. If false, this is skipped, we go to the next one. I mean, not skip, this is false, this block is not executed, we go to the next one. Okay, and the same here and until we reach else. So if all these if statements fail, then it comes to the else statement and then else is executed. Also, we consider the option where else is not used. In this case, it just simply goes to the next part of the code, which is out of this if statement. But this if is considered as one if structure, because all these ifs and else ifs are related in a sequential way. Okay, the question for when can I add another if after else No, else is the closing part for the if statement. Of course, you can write another if statement, but this will be considered as separate if statement. You can have, as I shown here, you can have multiple if statements. Yeah? But one if statement is considered by starting at if, and if we use else, then this will be the finish of this if statement. Otherwise, it will not make sense, because if you have if, then you say have else if, you say else, and after that you say else if. It's not possible, because else means that that all the cases above are failed. Yeah, so in this case again, go from top to down, and else just basically means that all the cases above are failed. Yeah, and otherwise, if we have, for example, if after else, then this doesn't make sense, because the case else is already basically in theory you could, I mean, C# will not allow you, but in theory you could do it, but it would be just unreachable code, because from the programming point of view, this part would be unreachable, because else statement is just the default one. If everything above fails, then else is executed. If at least one of the above is successful, then all the code below is not checked. I mean, not the code, but the parts of if statement are not checked anymore. So this is the part of the code. Yeah? I mean, this is one if statement which starts here and finishes with this block, and the whole structure of the statement. What happens outside this this part, that's another code which works independently from this if structure. Okay, so maybe any questions? Clear, not clear, some many things. Okay, then if no questions, I guess we can finish for today. So yes, so please share then your, so for those who have not shared with me yet, you can share them then until the end of this week. Also, yeah, there was the question from Maria about the groups. So can anyone, if there are some, yeah, I mean, the size of the groups is not important, so just any team. So please take Maria. I mean, the idea will be quite simple. We'll just simply all need to work on the same repository. Yes, so please, any group required to Maria, just take Maria in your group, please. So, and I hope that and repositories, please send me Discord chat. You can send me privately, then I can check it. Yeah, individuals, yeah, and also for individuals, please provide the GitHub repositories. Send me in Discord chat privately, or if you want, also you can share publicly. No, I guess you can send privately. In Discord chat, if maybe more comfortable for you, you can also use email or anything else. Just it doesn't matter. You can contact me any way you want. But yeah, preferably this would be Discord chat. Me privately. This would be so. Okay, yeah. So then, thank you all. It was a long week for everyone, yeah. So we can have a nice weekend, have a nice rest, and then see you all on Monday then. So bye, and have a nice weekend.